Hi friends, welcome to follow up. Let's have a look at problem 1658, minimum operations to reduce x to 0. And in this video, we're going to explain a solution based on the idea of reduction of problem. So we're going to reduce this problem to a very well-known problem, and then we solve it. So here we are given an integer array called nums and an integer x. So in each operation, we can either remove the leftmost or the rightmost element from the array nums, and then we subtract its value from x. Note that this modifies the array for future operations. So we want to return the minimum number of operations to reduce x to exactly 0 if it's possible. Otherwise, we are going to return -1. So here are three examples. The second example, basically, it's impossible, so we return -1. So you can see all the numbers here are larger than x, right? So it's impossible to get 0. So in the first example, so the operation is 2. So actually we have 2 and 3 in the tail. And in the third example, we have 5. So the 5 basically corresponding to this. This is 3, 2, right? And also we need 1, 1, 3. So in total they have sum 10. So this is the three examples. So the constraints are the following. First, the length can be up to 10 to the power 5. In other words, we need to consider term complexity. And the elements is positive, and x is in between 1 and 10 to the power 9. So with that said, we are ready to do the analysis. So this problem actually is very straightforward once we realize or think in the other way. So basically, we term it as reduction of the problem. So we can assume that capital S is the sum. Then this problem actually corresponds to find longest subarray in nums, with sum equals s capital X minus this little x. So for example, if we choose this one, then what left is this, right? And it's possible that you choose some from the beginning and some from the tail, and then have something left. The something left is actually a subarray, right? The subarray has a sum capital X s minus x. So what we want to do actually is to find the longest such subarray, right, with sum equals capital X s minus x. Then the return will be the length of the whole list minus the longest subarray length, right, we find. So this is the idea. So here you can look at example 1. So if we want to find the longest, because the sum is 11, right? We want to find subarray with sum 6, the longest one. So here we have 2. One is 1, 1, 4, right? So this length is 3. The other is 4, 2. This also sums to 6, but its length is 2. So this length actually is a complement of the minimum operations. So in other words, we want to return 5, the length, minus this length, 3, that is 2. So this is the first example. But find the longest subarray in nums with a given sum or given target is a standard problem. Or we can even reduce that. Find subarrays with sum equals to the target, or we count such arrays. How many such arrays has sum equals a target? So all these are known problem, right? So now let's follow this line to do the coding. First, let's just translate this strategy into code. So let's find sum, this nums, right? So we have capital S. So our goal is to find subarray with sum equals capital S minus x, right? So here let's also get the length of this list. It's just for convenience. Then first I want to check an edge case. So in other words, so if goal equals 0, in other words, we want to find subarray. So the subarray sum equals the x, right? So in this case, we just need to return n, right? the length. And then let's do another problem. It's find longest subarray with, or it can be sometimes can be multi subarrays with longest subarray with sum equal to go, right? So with this we can use a dictionary, right? So 0 we use -1 as index. Let's see. What we want to do is, right, using prefix sum essentially. So let's denote the result to be -1 first, and then the current will be 0. The reason is we want to find the longest one, right? So we set to be -1 is good enough. And then we are going to iterate. So for I, y in enumerate, that's the nums list. And then the current is a running variable. It's going to be cumulate. And then what we want to do, we want to check if current minus go in the dictionary. So this value of this key corresponding to the earliest index that this sum appears, right? So what we want to do is let's introduce the variable, the temporary, just for start index. So it's d, right? Current minus go. It's just for convenience or for explanation purpose. So this start index is the index ending at which the partial sum has a value like this, right? And then so what we want to do, because this current then from starting from this index onwards, so we are going to have a sum equals this go. So we are going to update this result, because we want to find the longest we maximize. So this will be currently we are ending at I, right? The start index is actually this one, right? We are starting from here, right? And then this is the start index for the part with sum equals to go, and then we need to add 1 back. So this is basically nothing but I minus the start index. So that's why we also initialize this dictionary using -1, because if we have a partial sum equals 5, then what's the length? It's -1, right? Start from index 0, the one after -1. So this is the one. Another one is that if current not in dictionary, so we're going to do this, current equals I. So this check basically tells us that for a value, for a partial sum, say let's say current, so the corresponding value in the dictionary is the earliest index that sum appears. Why we use this? Because we want to find the longest subarray, right? So with that said, we are ready to return the result if result does not equal to -1. Otherwise, we just need to return a result or -1. So with that said, we are ready to do a test. So the answer is wrong. Let's see what's the problem. So we have 114 current minus go in D, right? Start index. So it's D, and then we do max. So sorry, this is not return index. We should return n minus result, because this result is the longest subarray length, right? We need to use a complement. Let's do a test. Yeah, it passes the first example. Now let's do a test for generic case. Yeah, it passes all the generic cases. So with that said, basically that's about it for this problem. So actually in this new try, so we made several mistakes. It's due to this return. So we need to return n minus result. So with that said, that's about it for this video. Thank you.